Hello everyone, what's going on? In this video, I'm going to be teaching you about how you can plot graphs in Python using matplotlib, and I will be discussing about a package which is called Numpy. This package is actually used for numerical computation in Python, and it's way faster than inbuilt Python data structures. So let's get started, and before using any of the packages, first make sure that you have installed these packages. So if you want to install this package, open the terminal, or if you are using Windows, you can open the command prompt. Now after opening the terminal, just okay, if you are using the conda distribution of Python, just write conda, then install, then the package name. So first I'm gonna be installing matplotlib. So matplotlib, it will take some time to fetch the metadata, and well, you can see I have already installed these packages, so it's now asking me to update. I'm not gonna choose yes because I don't need the update at this moment of time. Now if you want to install the numpy, just type conda, then install numpy. And okay, in this way you can install these packages. I have already installed this. Now if you are not using the conda distribution of Python, you would have to use the pip or Python package installer. So in order to use the pip, you should have to type pip, or if you have two version of Python installed, then if you want to install that for Python 3.5, just write pip3, otherwise just simply pip. Now I have two version of Python, so I will be writing pip3, then install, then package name, which is matplotlib. You can see it's saying that requirement already satisfied, so I need not to install anything. Now let's try to jump into the main course. Now in order to use all the functions available in these packages, we should import these packages in our code. So I'm not using simple text editor and command line interpreter to run the Python script. I have created my own build system in this Sublime text editor. So if you want to learn how you can create your own build system and build and run Python script from this Sublime text, I can make another video. That's not the matter of this video. So let's try to focus on matplotlib and numpy. Now in order to import anything, we should use this import keyword and then the package name. So matplotlib is actually not a package. It's under pyplot. Sorry, if you want to import something which can plot the graph, then use from import matplotlib.pyplot. So this pyplot will be actually used to plot anything in Python. Now if you are feeling that this name is too big, you can give an alias to that name. So I will be using pt. So instead of pyplot, I can use this simply pt. Now in order to plot anything, we need to have some x values and the y values. You can store this x value in a list. Let's say these are the couple of bunch of values, and I'm creating another list which contains, let's say, 5 minus 2 3 4 6 9, and make sure that you have equal number of values. Here I have 7 values, and here I need to add another one. Now if you want to plot anything, just use this pt that we have imported and then plot. After that, give the x and y. X will be the list of x coordinate and y will be the list of y coordinate. Now if I run and build this, you will see nothing will happen. It's taking some time to import this package. In order to show this plot, just use this pt.show. You can see by default it's actually plotting a line graph. In order to plot a scatter graph, instead of using this plot function, I can use this scatter. It will create a scatter plot. Now let's try to customize this a little bit. Now if you want to give a color, you can give color as You can give any of the value of the color. It could be a single color, or it can be name of the color, or it can be the hex code also. You can find out the hex code of any color from internet. Let's say that I want to give this to red. If I run and if I execute this code, you can see the color is red. Now I can give it's not looking that great because I haven't give any title to the x-axis and the y-axis. In order to give a level to the x-axis and y-axis, we can use this x level method, and here we can pass the level. Let's say that this is x-axis, and using this y level method we can give the y level. Let's say this is y axis. Now if I run this code, you can see the level is added. Now let's try to see how we can add a title to this graph. Let's say that pt.title graph. Yeah, it has added the title also. So it's a bit of customization. Now if I want to add the lower limit and the upper limit for the x and the y axis, I can simply use this xlim, and here I can give the limit of the x-axis. Let's say this is from -10 to 20, and I can also give the y-lim right here, and let's say this is from -20 to +20. Now if I run this code, you can see it has added x-axis is now from -10 to 20, and y-axis is now from -20 to +20. Now let's try to do some useful data visualization for a big data set. So I have this data set called cgpa.csv. It contains data about 5 lakh students, and it has 3 columns. One is the roll number, other 2 is CGPA and rank. Rank is the university entrance rank. Now this file contains actually a lot of data. In order to efficiently analyze and visualize this data, we could have been done this manually, but the most elegant and the efficient way to analyze this data is to use the pandas module. So pandas is not inbuilt in Python. You should install the pandas. So go in the you should go to the terminal and then write conda install pandas, and if you are using pip, then just type pip or pip3 whatever, then install pandas. It will download and install this package. Now after doing that, you can import that to our code. Import pandas, and I'm gonna give that as I'm gonna give alias to that. Let's say that this is PD. Now instead of this x and y, I'm gonna be using some real data. Now let's try to see. Well, let's name a variable called data, and if I want to read something from a data set or a CSV file, I can use this read CSV method to read something from the data set. Now here I need to give the data set file name, which is cgpa.csv. If I print this data, it's actually a lot of data. It will not print all the data. It has given this roll number, CGPA rank, and here you can see some dots are given, so it will not display all the values. Now let's try to see. Okay, let's comment this out, and if you want to get a particular column from this data set, then you can use that column name in this square braces. Let's say that I want to get all the roll numbers, then I can give roll number. If I build this code, it has given me all the roll numbers. This thing is actually the row number. Don't worry about that. Then if I want to get the CGPA, I can write CGPA, and it has given me all the CGPAs. Now using these data, I can plot that easily. So let's try to get rid of this from this from all what I'm saying. Okay, let's try to plot these things. Let's say x is equals to no. Well, instead of that, I will be directly plotting that to this pt.plot plot function. Let's say that I want to plot graph roll CGPA versus roll number. So I'm gonna be writing here the roll number, x-axis will be roll number, and y-axis will be CGPA, and let's give it a color. Let's say the color is equals to orange. Now if I plot this, there will be problem. So let's try to see what the problem is. It's actually okay. Roll number should be. It will take a little bit of time. You can see it's a big orange square. It's because we have plotted data about 5 lakh people. We should not do that. Instead of that, I will be subsetting this data set, and I will pick up 50 elements from this front of this data sheet. Now if I plot this, it's taking a little bit of time. Now you can see it's nice looking orange line graph. Now let's try to plot a scatter plot over it. Let's try to experiment with this and scatter, and then let's change the color. Let's say this is blue. Alright, now if I build this code, and you can see a nice looking line graph and scatter plot over that. So I could have been given some levels to this. Let's say this is level is equals to line graph, and level for this is equals to, let's say, scatter. Okay, now in order to show these legends, I can write pt.legend, and if I build this code, you are gonna see, okay, so it's, say it should be this one. Okay, now you can see it has shown this legend right here. So that's a kind of cool. Well, I should give some title to this graph. So let's say that pt.x level is equals to x-axis is actually roll number. Then I can specify the color. Let's say this is green. Okay, the level will be colored by green. Then pt.y level. Let's say this is CGPA, and let's give a color of blue, and pt.title, and the color it's actually CGPA versus roll number, and give a color to it, and the color should be green. Okay, now if I build this code, it's looking cool. Now let's try to discuss about the bar graphs. So if I can plot this bar graph, that will be kind of cool. So if you want to plot the bar graph, then what you can do here, instead of the scatter or this plot, let's comment this out over here, and instead of scatter, if I use a bar right here and build this code, you can see a nice looking bar graph. Alright, now let's get rid of this thing, which is, okay, sorry for the interruption. Let's get rid of this label. Now if I add a edge right here, it will be a horizontal bar graph. You can see from this graph. Now what I can do, okay, I can specify the color of these bars. So instead of this color, I can give a list of color, so it will pick up colors alternatively from this list. Let's say that I want to color this entire bar graph using two color, let's say using green and blue. So I can write green and blue right here, and if I run this code, you can see it's perfectly working. Some warnings are there, I don't care about that. I can give a list of color over here. Let's say this is red, blue, and let's reduce this number to 30. Okay, that will be looking fine. Now you can see a cool looking graph over here, and I can specify some parameter right here for any plots, that is alpha. Okay, alpha is basically the opacity of the color. So if it takes value from 0 to 0 to 1. So if I the default value is 1. If I give 0.7, you can see the transparency is increased. All right. All right, so till now I haven't discussed about. Now let's try to go ahead and see how do I get these subplots. So in order to get a subplot, I cannot just directly plot that into this PT. So we would have to use something called figure. Now let's try to learn about figure. So I'm gonna delete all of this thing. Now figure is something that is a container for all the subplots. So in order to get a figure, I will be using a variable name called fig, and here I will be using pt dot figure. So using this pt dot figure, it will return me the figure or the container. Now in this figure, I can keep adding subplots. So in order to add a subplot, I need to, let's say that I want to add two graphs to this figure. Two graph can be treated as a subplot. Now in order to get a subplot, I will be using a variable name called graph1, and here I will be storing figure dot add subplot, and in this subplot method I would have to give three parameters. The first two is the dimension. It will be a bit confusing, but please listen to me carefully, you will get this thing. Now the first thing is that I need to give the dimension, number of rows and number of columns, that it's actually the logical division of this figure. So if I want to add two graphs to this figure, I can divide that entire figure into either 2 row and 1 column, or 1 row or 2 column. If I want everything side by side, then I will be writing 1 row and 2 column. That's okay, fine. Now again, the third parameter is I have divided it into 1 row and 2 column. Now in which cell I want to place this plot. So if I want to place this in the first cell, I can write 1 here. Now let's try to plot graph1 dot plot. Using this object of graph1, I can plot something in this subplot. Let's say that I want to plot CGPA versus roll number, and let's say this is data CGP. All right, if I go ahead and run this, you will see that there is this is added in the first column. I have divided this figure into two parts. It contains 1 row and 2 column. Here you can see there is a space for another plot. So let's try to add something there. Let's say that I want to get another subplot. So I will be naming it as graph2. It will be figure.add subplot, and then the logical division, 1 row 2 column, and then in which cell I want to place this. If I give 1 here, this will replace this figure or this subplot. So I should give 2 because I want to place that in the second cell. Now let's try to copy this piece of text, and instead of graph1, I will be writing graph2, and instead of roll number, I will be plotting rank. So the rank was okay, rank, simply rank. If I build this code, you can see it has plotted rank versus this one. Let's try to swap this out. Let's say this is rank versus CGPA. Now you can see it's now changed. So isn't that cool? Now if I want to plot this in 2 rows and single column, I can give something like this. I can write 2 rows and 1 column over here. Let's erase this. Okay, if I do that, you will see that this is plotted in this way. So now one thing you should note, that if you want to set the title and level of any axis or anything, I cannot use simply that title or level anything. So let's say that I want to set the title of the this first graph as CGPA versus roll number. So if I use this graph1 dot title CGPA versus roll number, then you will see that it's gonna throw an error. So in order to set any parameter for these subplots, I should add a set underscore before that. So this is set title, set color, whatever. So I have set the title to this one, and let's say that this is, I want to set the title for plot 2 as rank versus CGPA. Rank versus CGPA. Alright, so if I go ahead and build this code, you can see it's now perfectly fine. Let's plot this in 1 row and 2 column. 1 row and 2 column. Okay, that's fine. Now if you want to plot 4 graphs, then in order to contain 4 graphs, how you can do that? Obviously you would have to give 2 rows and 2 columns in, and each of the cells we will be placing one of the graphs. So we can do something like this. I can give 2 2 here, then 2 2 over here, then I can copy this code out, then over here I can give 3, over here I can give 4, and so on. Now let's say that I want to plot 3 graphs, and one graph should take all the entire row. How do I do that? That's the question. So let's try to copy this graph over here, graph 2, and I'm gonna copy that right here. And so I have given this 2 2. I am logically dividing the portion into two rows and 2 columns. Now I want this graph 3 to be in the place, it should take one entire row. For that I can logically divide this entire figure into 2 row and 1 column. I can obviously write that one over here, but the question is, what should be the value of this one? Actually I want to place that in the second place, in the second row, so actually in the second cell. So instead of 3 I should give 2. It's a bit confusing. Please listen to me carefully, you will understand why I'm doing so. Now I need something to plot over here. Let's plot the same thing again here. So instead of graph 3 I'm writing graph 3 instead of graph 2. Let's try to run this again. You can see now this third one has taken this entire row. Alright, now let's try to see how we can use how we can customize these subplots. So if you want to okay, let's try to run this again for one more time. If you want to set the color, this background color of this figure, you can use in this figure, okay, you can use this fig dot patch, and then set face color, and here you can give the color whatever you want. Let's say I want to color it by gray, so I can write gray over here, and I can run this code again. You can see it's now gray background. What about these plots? So if you want to customize these plots, you can okay, in this add subplot you can mention the face color. Let's say this is yellow, this is let's say this is light green. Alright, so now I can give the color. Let's say this is light gray. It will not look that great, but this is for the illustration. Alright, this must be the face color. This should be the face color. Alright, you can see it has colored these things. So now that's it, and let's try to talk about the last one, which is pie chart. Now let's learn about pie charts. Let's assume I want to see how many students got 9 points and how many students got 8 point and 7 point and so on. The pie chart will be the best option to visualize these kind of data. So I will be using this original data set. Let's name it as data 1. So I have named it as data 1. I'm not gonna take the smaller data set, which is data. Now from this data 1, I will store that into X. How many students got has a CGPA over 9. So for that I will be just writing data1, then data1 dot cgpa, then greater than equals to 9. If I write this code and print this out, you can see it has written all the students who got over 9, but I just want the count. So for that I will be simply using len. Alright, now I want two other things, which is x1, which is how many students got over 8 point but less than 9 point. So how many 8 pointers are there? So for that I will be writing two queries in this using this AND operator. The first one is data1.cgpa greater than equals to 8 and data1.cgpa less than 9, and x3 will be simply length of this dataset, data1.cgpa less than 8. Alright, in order to plot okay, let's delete this print statement over here and let's delete this plot over here. In subplot 3 I will be plotting this pie chart. In order to plot a pie chart I will be writing graph3.py. Then here I need to give a list of values. So list of value will be simply x1 and x3. Now I can specify the colors and I can give a list of color for these. So color will be, let's write yellow, orange and red. If I go ahead and run this code, you can see pie chart has been plotted, but this pie chart is not looking that great. So it's actually looking a oval shaped pie chart. Let's make it circular looking shape. Now if I want to make it circular, then I will have to write graph3.axis, then I should pass this equal. It will make this major axis and the minor axis as equal size. So let's run this code again. Now it's actually pie chart, but there is no label on it. So in order to add any label, I should specify the label over here using these labels. Now labels should be, the first one is 9 pointer. Let's write 9 pointer, then 8 pointer, and the last one is others. Alright, now if I want to show this as a legend, then I'm gonna be writing graph3.legend and I can give a title as description. Alright, so you can see now it's a nice looking pie chart. So that was all about pie chart. Now let's try to discuss about the numpy. Numpy is used for numerical computation in Python. It's way faster than many of the inbuilts. So let's try to learn about numpy. So I'm gonna delete all of these things, and now here first we should import the numpy. Import numpy as np. I'm giving a name np to it. Now the fundamental building blocks of numpy is n-dimensional array. So if you want to create an array, let's say arr, then you should use np.array, and then here you need to pass a list of values. So let's say this is 1 2 3 4 5 and so on. So this is actually an n-dimensional array. I can print this object over here. Let's try to run this code. It has printed this array. Now let's try to explore the power of this numpy array. If you want to create a two-dimensional array, you can pass a list of list, because two-dimensional array is nothing but list of list. Let's say this is 5 6 7 8. Alright, you can print this entire array using the array name, or you can access individual element by using two indices. So let's say that I want to add value from the second row, so that will be 1, and then the second row, fourth column. So this is using these two indices and this comma, we can access any element in this numpy array. It has returned that element. Now I can check the data type of this array using arr.dtype. I can run this code. It has returned this integer 64. So this is actually array of 64-bit int. Now what I can do here is I can also check the type of this object using type then array. So it has actually written that it is n-dimensional array of np. Now I can get the shape of this array. Shape is nothing but the dimension. Using this arr.shape, you can see this is now 2 4. So what happens if I want to change the shape of this? I want to transpose this matrix. So for that I can write arr.shape is equals to, previously it was 2 4. If I write 4 2, let's see the magic. It's now 4 2. All right, but if I print this, you can see, ta-da, it's actually converted. It actually transposed this matrix. You can do a lot of cool things with NumPy. Now the question comes in your mind, why do we use this NumPy instead of using the inbuilt? Because NumPy is actually way faster than inbuilt list. If you don't believe me, let's try to measure the performance. So what I'm gonna do here, I'm gonna create a list of 2 lakh elements, and then I will be increasing all the values by 2. So I will be performing this operation for inbuilt list as well as for NumPy, and I will be measuring how much time it takes. In order to measure the time, I'm gonna import time. So this time will help us to measure the time. So first let's try to make a comment like inbuilt list operation. Now I'm going to define a list which contains let's say 2 lakh zeros. So now I'm going to measure the time. So let's say t1 is the time before performing any operation. This t1 will give us time in seconds, so I can multiply that by 1000 to get in milliseconds. Now let's try to run a loop from in range 0 to length of this list. Now I can write L0 is equals Li plus equals to 2. It will increment this list by 2. Alright, now after performing the operation, now let's measure. T1 is now equals to it should be time.time. Okay, now current time minus the previous time. Okay, current time multiplied by 1000 because I am measuring that in milliseconds. Now let's try to, okay, this was all about the inbuilt. So I can print the time time taken by list is equals to plus t1 plus milliseconds. All right, now let's try to do the same thing using what you call a NumPy. So again, initialize this list by 2 lakh numbers. All right, now what I can do here, I can create an array. Let's name it as L, then it is np.array. Then I can pass this list over here. Now if I want to increment this, I can write L is equals to L plus 2. Alright, okay, before doing that, let's try to take T2. T2 is the time before performing this operation, and then T2 is now let's multiply this by 1000. Alright, now time multiplied by 1000 and then T2. Alright, now I can print time taken by NumPy array is equals to, then I can write T2 over here, then millisecond. Alright, let's run this code and let's see. It's saying that cannot convert float to str implicitly. Okay, so I can write, instead of this I can use a comma. Instead of this concatenation operator, I can use a comma over here, and let's try to see what happens. st1 is not defined, it's t1. Alright, array is not defined again. array is not defined. What's wrong in this code where I have written array? Okay, why I'm okay. Now let's build this code. You can see the difference. The first one has taken 32.55 milliseconds, and the Numpy array is taking only 0.65 milliseconds. Let's run it again. Alright, you can see 27 millisecond and only just 0.60 milliseconds. So it's actually 50 times faster than inbuilt. Now, if I increase this to 20 lakh, let's try to see what happens. You can see again it's way faster than Numpy, almost 5 times, 50 times. So that's why we should use Numpy for any kind of numerical computation. Now let's try to explore some of the powers of Numpy. So it's actually a huge library, so I cannot discuss about all the functions. So now let's try to see what I can do. Okay, Numpy has a certain function like, if you want to do any kind of operation with the list, you can just pass this array name and then assign that by changed value. Like if I want to multiply all the elements by 2, I can write L multiplied by 2. That's it. Now what happens if you want to get a mathematical function like sine? Now let's say this array, okay, you can generate a range of random numbers in Numpy like this. Let's say arr is equals to np dot random dot random. This will return a list of random numbers. Let's print this array. Okay, it's actually gonna return one single random number from 0 to 1. Now if I want n random numbers, I can write n and then number of random numbers I want. It should be rand n. Okay, rand n. You can see it has written 10 random numbers. Value is different. Now if I want to get integer random numbers, I can write rand int. Then I can give let's say from 5 to 10. It's gonna give me one random number. What if I want to generate n random numbers, rand int, I can write, I think I can write like how many random numbers I want to generate. Yes, I can do that. So that's kind of cool thing I can do with Numpy. Now let's try to do a certain thing like I can use this np dot. Okay, let's say that I have a list which contains some values like np dot array. Then I have some angles like 3.4, 1.2, 6.6, and let's say 5.5. Now if I want to get sine of all of these angles, I can write something like this: print np dot sine then x. Let's try to see. Okay, array is not defined. I'm gonna delete that. Let's try to see what happens. It has returned all the sine values. Now let's try to do a cool thing. I want to plot a sine graph using Numpy array and matplotlib. So how do I do that? So for that I need a number between a range. To get a number in between, to get evenly distributed number in between a range, I should use np.linspace. Let's say that I want to get numbers from minus pi to minus 2 pi to positive 2 pi. For that I should import from math import pi. I need just only this pi constant. Then I can write minus 2 into pi to positive 2 into pi. Then how many numbers I want? Let's say that I want 360 numbers. So I can write 360 over here. So if I print this, you will see it will return 360 numbers starting from this position to this position. So let's try to see how I am getting this. So it has written all the 360 numbers. So how much difference in between that? If I want to see the difference, I can write ret step is equals to true. It will also return the difference between two consecutive numbers. So the difference between two consecutive number is this one, 0.035 and so on. So now I got the thing. Now I can plot a sine graph. In order to plot a sine graph, what I need to get f of x. So let's say f of x is equals to np dot sine then x. All right. So if I want to plot fx versus x, then I need something to plot. So pt dot plot then x versus fx, and then I should write pt dot show. Now I can build this code. You can see a nice looking sine graph is plotted with the help of Numpy. I can make it as a scatter plot, scatter. Then I can specify the line width as 0.5. Let's see what happens. It has also given me this scatter plot. So I can reduce the values also. Instead of 360, if I write 50, the number of values will be reduced and it will look like more scattered. So that was all about matplotlib, numpy, and a little bit of pandas. So if you like this video, please subscribe to my channel. Thanks for watching this video.